All right, we're looking at L'Hopital's rule, which is a useful tool for dealing with limits that are, in an indeterminate form. And when we first learned about limits at the beginning of calculus class, right near the beginning of the year, we learned a lot of ways to handle some indeterminate forms. For example, if you look at this example down here that we'll do in a minute with L'Hopital's rule, you can already do that one, even if you don't know L'Hopital's rule. Um, the first thing we normally try is direct substitution, where you would plug 2 in, right? And you'd get, 4 minus 4 over 4 minus 4, 0 over 0. I'll show that in a minute. And we talked about some different algebraic strategies to deal with a limit like that. We would, in this case, factor, reduce, and then try direct substitution again. We also learned some tricks for if there's a square root involved, where you'd rationalize the numerator maybe, or where there's fractions in fractions, and you can multiply by a common denominator in order to help eliminate the whole, the factor that is on top and bottom that's giving you 0 over 0. So those are all things you've done before, but now we have this other trick, and L'Hopital's rule, it works on those. It also works on some problems that might be a little tougher, involving trig or inverse trig or logs that are harder to do algebraically. So it's pretty versatile. It doesn't always work, though, in cases where it seems like it could. I'll talk about that in a minute. So here's the basic rule itself. If you're trying to find a limit as x approaches a of f of x over g of x, and by the way, this also works, a implies a constant, but this will also work for limits at infinity. So in place of a also works for x approaches plus or minus infinity. Okay. What happens is, if you have a limit, this is where you can use it, right? If you have a limit where direct substitution gives you one of these indeterminate forms, 0 over 0 or infinity over infinity, or any combination of positive or negative infinity over positive or negative infinity. In those cases, you can use L'Hopital's rule, and here's what it says. It says that the limit as x approaches a of f of x over g of x, so this problem that we started with, will be equal to the limit as x approaches a of f prime of x over g prime of x. And so once you kind of get the hang of it, it's pretty easy to use as long as you can do derivatives reliably. I do want to point out one thing right away. It's tempting because we're taking derivatives of the top and bottom, the numerator and denominator of a fraction. It might tempt you to do that when you're taking a derivative of a fraction, but remember, we still have the quotient rule. So if you're ever taking the derivative of f of x over g of x, you can't do this, right? That's what we wanted to do when we first learned derivatives before we learned the quotient rule, and it was wrong then, it's still wrong. Some calculus teachers call that the idiot's derivative rule or quotient rule. Don't do that. Don't be that person. You only are taking, this is like the only context I can really think of. There might be something else in, later on in calculus where you're going to take the derivative of a numerator divided by the derivative of a denominator. It's within these limits to use L'Hopital's rule only for that purpose. Okay. So here's this example, this pretty basic example. And again, you could do this one without L'Hopital's rule, right? You could factor out an x on top. You can factor the bottom as a difference of squares, and you'll be able to reduce an x minus 2 factor that is responsible for the 0 over 0. And then you could just plug in 2 again and get an answer, right? However, I'm trying to show you L'Hopital's rule here, so let's do it. First of all, I do want to make a point. If you're going to use L'Hopital's rule, you don't want to write, don't do this. Let me spell this out in case anybody's just kind of watching. Don't do this. Don't write equals 0 over 0. It's tempting, I know. Don't. This is incorrect. Okay? What you're saying is that this limit equals 0 over 0. But if you think 0 over 0 as a value, what is that? That is undefined, right? And this limit is actually not undefined. It has a value. We're going to find it in a minute. So saying it equals 0 over 0 is an incorrect statement. and you will lose points on an AP exam for that. You would lose points on an exam in my class for that. Don't do that. Okay. Now you kind of want to verify for yourself that you are getting 0/0. So, if you need to do that off to the side with some scratch work, scratch work where you don't write equals, right? And you're kind of like, okay, 4 minus, 2 times 2 over 4 minus 4, 0/0, right? You verify that. You can do that, whatever you need to do. Don't connect it to your work here. And then to justify using L'Hopital's rule, which you do need to do, you have two choices. You can either write is of the form, or the, let's say, indeterminate form, zero over zero, or of course infinity over infinity if you had that. And then you can say, therefore, by L'Hopital's rule, and write what it equals. Or what I like to do is show the limits separately for the numerator and the denominator. I like that because it's a little less writing and it's mathier writing. So the limit as x approaches 2 of x squared minus 2x equals 0. That's true. And the limit as x approaches 2 of x squared minus 4, that equals 0 as well. And so I've shown the 0/0 by separating the numerator and the denominator, which is valid, right? I didn't write anything that's undefined there. So now what I can do is rewrite this limit and say this equals, by L'Hopital's rule, this equals the limit as x approaches 2 of, and we're going to take the derivative of the numerator, 2x minus 2, right? Just using the power rule. Derivative of the denominator, 2x minus 0. And now I can plug in 2, and I can see that it's going to work, right? I'm not going to get an indeterminate form. I'm just going to get 4 minus 2 over 4, 2 over 4, 1/2. And that's it. That's my limit. Okay? There will be times where once you do that one time, you'll get 0/0 again, in which case you can actually do L'Hopital's rule again, right? There will be times where there are some times where L'Hopital's rule fails. One notable example is if you have, and I don't have an exact example in front of me, but if you're taking a limit where there's like a square root of an x squared and maybe some stuff on top, and there's like just a linear function on the bottom, sometimes L'Hopital's rule will basically just make these switch places, and you could do it over and over again. It'll just keep going back and forth. In those cases, you want to go back to one of the algebraic approaches that you learned in the beginning of the year, and those are a little tougher maybe. But it works a lot of times. And it even works on the AP exam on some of those definition of a derivative problems, which it's kind of a circular reasoning way to approach them, but it's effective and it gets you the right answer and it's valid. So I'll maybe make another video going through one of those at a different time.